I've been told I've got time pressure. I can't keep you away from food, so we'll try to make it quick. I'm excited to say here is a panel that's not on AI. So there's more capability in Australia than just that. But lasers, and I think the easiest way for me to describe why is to ask the panellists. So I'm going to start with Warren. And Warren, I'm going to say, why lasers?
Well, lasers are nothing new. In fact, it was actually an Australian won a Nobel Prize for the discovery of the science that led to lasers. The type of lasers, though, that this group is talking about are short pulse lasers. So another Nobel Prize in 2018 was won by being able to compress a laser pulse to very, very high energies. So consider these types of lasers like a big hammer or a big camera flash. And that opens up a whole new range of possibilities in terms of what they can do. Incidentally, another Nobel Prize was won about 2 weeks ago for their applications in chemistry. So these short pulse lasers are new technology. The evolution of this technology is moving faster than Moore's law. The number of applications that are available are enormous, and I think this is a very nice panel that reflects 3 Australian efforts to try and explore different application areas. And the final point is going back to one of the key requirements for the capability papers. Why Australia? Well, Simon Poole's written a very nice article that Australia has quite an extensive photonics industry. Photonics industry is the broader space in which lasers sit.
Photonics is something that we've got a long history with and lots of experience. I mean, all the way back to radio telescopes and a whole range of different legacies. I know I've got a chairman, or a board member from that industry with Mets Ignited. But I might go to Miftar and get from your perspective, what's the implication, what's the opportunity of lasers for us here in Australia?
Well, can you hear me? Or is it,
yep.
So thank you for the invite. As Chief Scientist and Professor Munro said, the high energy lasers or continuous lasers is used until current offer an infinite magazine. When you have to deal with the USPL lasers, they offer a train of pulses. Imagine a bullet fired, but you have hundreds of thousands of these bullets fired in a continuous way. So that's kind of like when you talk about the direct energy and what we have developed in Australia, especially as part of a DSDG in University of Adelaide, we have focused on something unique, which is in high energy rep rate and short and ultra short pulse laser systems, and hence we're trying to explore all the other applications, starting from medical, scientific, fundamental, because we have to stay innovative, as we have all trying to do that, but also what's most important is that, as Warren was naming the Nobel Prize laureate winners, has attracted a large number of pool of students wanting to do work on this field. And we are the ones we build them in a lab. And it's an exciting time to be in the field, which offers, like Warren said, chemistry. There was a prize winner Nobel in 2002 for a lobby using femtosecond lasers, for example, and all the electron dynamics and all the microstructures you can reveal with these lasers, which it's an amazing opportunity for us in Australia to have some of these lasers built in here. And currently, we're trying to explore with industry, such as HP11, Becker, and Thales. And also, we have a Thales scientist here from France. Thales would delivered large-scale lasers for ELI infrastructure, Extreme Light Infrastructure, European Union. So we're trying to glue it together, a partnership here, where we can do, as one of the early strategies published from Defence under the More Together umbrella, to deliver that punch that we need for our ecosystem in Australia.
And I think we talked about capability instead of sectors in the previous panel. So maybe now we've got capability. Now what's its applicability? And I might just turn to you, Frank, to sort of start us off with where does this fit into the ecosystem?
Yeah. This is a very good question. That laser is not that far away from people's daily life. It's not only the high power laser used for defense or space technology. Laser has been used everywhere, but probably people in our daily life didn't recognize it. If you think about the application-wise, medtech, all the medical devices, let's say the our phone, the cutting the glass, the energy, new materials, alternative materials. A lot of so much things are actually manufactured by laser technology. But what we are talking now here in this panel is more focused on the ultra-fast or femtosecond short pulse laser, which can be regarded as the code manufacturing process. So at Innofocus, we think we are the first company, deep tech company, commercialized equipment that can do intelligent laser nanofabrication at 100 nanometer scale, even lower. The idea of doing this manufacturing is we can not only produce new manufacturing performance, but also to recharacterize the physical or chemical or biomedical characteristics of the material. Meaning we are creating new materials that don't exist in the natural world. Yeah. For instance, solar thermal materials or self-cooling materials with nanostructure, or kind of materials can be used for medical devices, can be used for optical sensing, optical computing, including the quantum. What is really important, I think, to this point is actually, if you look at all the categories, the applications or the research categories under the NRF, also the research and science priorities, they are all enabled and supported by photonics technology. So whether Australia can have such kind of manufacturing capability for the future, it's very, very important for us.
So we're struggling with valves, but we can do lasers, is what I'm hearing as a takeaway. But no, the interesting thing for me is this has also got a clean energy implication, and there's a whole, future focus around the application of this technology. Warren, you were talking about it before, maybe sharing with the audience some of those opportunities.
All right, so HB11 Energy, what we're trying to do is develop, develop boron as a clean energy source. If we can do that, we will have an energy source which is about 100 times, would be able to produce about 100 times more energy than all of the fossil fuels that have existed on Earth. And right now, there are no single replacements to the carbon transition other than a new energy source. In scale, with respect to solar and wind, and most people understand their limitations. Now, we were going to do this with, achieve fusion with hydrogen and boron with lasers. And up until 10 months ago, we were cowboys. There's other ways of making fusion. Lasers are never going to work. Until it worked. So 10 months ago, the National Ignition Facility, albeit with different fuels, got, what in my opinion is the most significant scientific development of the century. They got net energy gain. And going to their conference a couple of weeks ago in Denver, of the community that did that, they haven't just done it once. They're up to 7 times and have got a gain of 2. The way they're doing that is they're turning up the power. Now, they're breaking things when they're turning up the power, admittedly, but they're also that has set off plans in the US and many other parts of the world to actually make fusion energy a reality. Now, to make fusion energy a reality is no small feat, and certainly a small Australian startup company is not going to be the way to do that. But right now, many companies or many countries in the world are establishing national strategies, US, the UK, Germany, Japan, and also China, to try and take advantage of this new industry which is evolving. And a lot of that industry will be built by the driver of these fusion energy power plants, which is going to be these short pulse lasers. Now, what we want, both for HB11, is to drive the strategy towards hydrogen-boron fusion, being a non-radioactive fuel that's very abundant. But also, the construction of the first fusion power plant, which the US Energy Secretary has announced is going to be within 12 months, or in 10 years. They've announced that several times, to the great anxiety of the laser fusion community. It's going to be done by large-scale public-private partnerships. So the question which, if people are asking the question about how might we be able to spend some of the National Reconstruction Fund money, infrastructure which would give Australia a seat at the table to become part of one of these international public-private partnerships that delivers the first fusion energy power plant is something which Australia absolutely can deliver, and that would be in the form of a national laser facility.
So is this a example of we're sitting on the edge of the potential to keep something or lose something? Because I mean, we've lost a lot of great things overseas, and maybe that's where they needed to go to scale. Though I've got my own views on scales, which anyone over lunch who wants to talk about scale, come and talk to me. But is this something, if we don't move now, we're going to miss it?
Absolutely. And similar to Australia's discovery of solar cells, an Australian invented or discovered fusion, including the hydrogen-boron fusion reaction. Most of its development has been pioneered at UNSW. If we lost it, it would be another national atrocity.
Wow. All right, so we've got a track record there. So if we want to change something, that's maybe the thing we need to change. Thoughts on how we might do it differently?
Laser fusion is really exciting, there's no doubt about it, but we're working with HP11 and developing some of the lasers towards that. We're not the scale of Lawrence Livermore, of course, but what's interesting is that while developing those lasers, we're learning that those lasers can be used in multiple disciplines, multiple areas. And what's interesting is, as we know already, Australian manufacturing GDP is, I don't know the correct number, but it is around 4%. And when building the lasers or these photonics capability, we are all manufacturing in-house. So that means that we have a chance to turn the tables around and remove from 4 or 5 or 6. Like one of the examples we mentioned, Estonia a lot, they generate, I'm not sure correct, but around 15 to 20% of their GDP from photonics market. We're talking about a small nation of 1.5 million, and they have ability to go toe-to-toe with giants like Germans or French, and I don't see why Australia can't. And Australia has the ability and the visionary people to see this as a big opportunity.
Frank, thoughts?
Yeah, fully agree. Cannot agree more. So if you look at the application we have been doing, we say at Innofocus, we try to reinvent manufacturing at nanoscale. When we say reinvent, we mean two things. One is to introduce the new laser nanofabrication capabilities to the existing industry to help them to produce better performance miniature devices. This is pretty good sample that we've done. So if you can see, there's an Einstein face on it, but it's very colorful. It's rainbow colorful. The reason it's colorful is because we have nanostructure in it. You cannot feel it. And also we manipulate the optical spectrum. So it can be used for digital ID, can be used for a lot of different devices, and we are developing waveguide, lens fiber. We are developing fiber Bragg grating sensors. So these are all very important components for the future quantum photonic chips. When we talk about quantum computing, it should be based not only on the soft capability, but also the hard capabilities. And also, if you look at today's energy alternative solutions, they need new materials. By introducing new nanostructures into whatever material, starting from polymer to ceramic, graphene, diamond, ceramic, we can develop new materials. These new materials will have broad application in all sectors. So when we say reinvent manufacturing at nanoscale, the most important thing is we revolutionize the new devices, the new materials that create a new future for human being. This is crazy important, and Australia has the very good positioning to pioneer this industry. We are never lack of innovation. We are not good at commercialization. But photonics and optical side, Australia is really good in terms of research. So that we are a industry partner of ARC, CRC, but we need the entire community, the ecosystem to realize we have this potential and do it. Yeah.
So I'm going to give all of you a 30-second magic wand. So if we want to keep it here, what do we need to do?
We need to copy Europe's model that has been replicated in the ELI infrastructure, the Extreme Light Infrastructure Program, which was one of Europe's ways to stimulate the economy in Central and Eastern Europe. They have spent $800 million on high-intensity laser infrastructure in the Czech Republic, in Romania, and Hungary. 2 weeks ago, I was sitting in their offices talking about bringing our projects to them. Wouldn't it be amazing if we could do that here, so we would be a magnet for people coming to us and claim the same economic benefit that their project is being very successful at?
Well, that's a good magic wand. Frank?
Yeah, I think the three words are aware. We need to be aware of we have these capabilities. Second is to build. That's why we have invested to build a 1,000 square meter facility in Melbourne, which we call nano manufacturing plant, and we have open labs in it. The third one is collaborate. We need all the industry that we have, research institute, to collaborate to find out how we can grasp for example, the quantum photonic chip market is $60 billion in the next 6 years' time. How we can seize this market, this is a question for us.
And before I throw to Miftar, I'm going to say questions in the room. Please put your hand up and the microphone will come around. Yes?
I don't want to repeat Warren and Frank, but what we're aiming to do and what we're planning to do is that do a slightly different way, not copy Europeans or US, but offer our own technology that we've been developing for years, so that not that we can offer that, leverage what Warren is talking, but offer in a different way and potentially in a more efficient way, so that Australia can have a place in the global market.
So copy the model, do it locally. How about the support? What do we need from investment and support? What do we get today?
I hope we get an opportunity to write a white paper for overall industry and how we see it as a platform to move forward in Australia.
Can I add just one word? Yeah, I talked to the Australian Manufacturing Growth Funding, which is managed by the big banks in Australia, and they said that at least you need to have $2 million revenue, and as a startup, I have only 1.8, and that was not possible. How could an SME or startup have $2 million Australian dollar revenue in the first 5 years, like the deep tech we are doing? We need to have the investment. We need to have the investment strategy. Yeah.
We've got a question over here.
Thanks, everyone. My question, just going back to what Roy mentioned about missing the industry in terms of complex manufacturing, that we lost it. I'm assuming, I don't know, in the device, in the products that you are going to make, because we are contract manufacturer, we are making hundreds of different products here in Australia. We see a lot of companies are failing, not because of lack of investment. Most of the speakers today, they talk about not having enough access to funding. What we see is that a lot of companies are failing because they can't get a few components when they want to, very fast track the commercialization. Like Jehan mentioned that he's waiting for that valve. So no one is going to make it for him in Australia if he just needs 1,000 in the next 1 year. He needs to find it from overseas. And he's an innovator. He's not in a position to find what is in China, what is in Germany, what is in Malaysia, what is in US. It should be a tier 1 contract manufacturer in Australia. We don't have it. Most of them are in Taiwan, China, US. There are 2 of them in Canada. There are few in Germany and UK, but nothing is in Australia. That's the gap. The integrated supply chain of lots of parts, which is going to make a finished product. I'm assuming in your product, maybe there are 4 or 5 elements that is going to make that's a difference between what is existed now and what you want to make as a product or device. How do you want to tackle that? Are you going to make those few elements? If I'm wrong, you can correct me, but is it something that you need to have access to a supply chain of 95 parts and there are only 5 parts that you need to just customize it to make your own technology here?
I can answer part of your questions. It's a good question because this is all about your strategy, right? So definitely we have, as a startup, this is the 6-7 years of our development. We have our development strategy. We start from developing the machine. And enabled that machine, we develop miniature devices. We sell the devices. And we're developing new materials which can be used for logistics. We are collaborating with Western Sydney University on the greenhouse, etc. But again, you cannot only rely on the external investment. Yes, you have to collaborate with the leading industry partners, or you have to find out the low-hanging fruits which can be commercialized quickly, and to get a revenue stream and feed the team and make the business survive. It's not easy. It's not an easy question. But as a management of a startup, you need to think big, act small, and try to scale out fast. Yeah, that's
Sorry, just rephrase my question. Sorry, Adrian.
I think we're going to have to wrap for lunch. So you're going to have to ask the question over lunch.
Quick one, just rephrase it. Your main challenge in scaling up, what is your main challenge beside of funding? Is it material? Is it the know-how to put everything together? What do you think as the main issue?
a lot of challenges.
Hard to pick
Running
one.
a company is not, there's no simple answer.
Oh, an exceptional question.
Exceptional question. My question is about, fusion undoubtedly is fantastic if we can get it to work. Now, fusion in the magnetic sort of confinement sense has been always 50 years away, and who knows how long it is now. I don't know what the lead times are for your technology, and I'm sure when it gets there it'll be great, but we don't have a lot of time, right, currently to decarbonise. And I was interested in your sort of remark about, we all know the problems about solar. And I just want you to sort of tell us a bit more about what they are, because I see currently companies investing a lot of money putting together solar. If you look at the solar flux on the land that we have globally, we have a disproportionate amount of that, looking at our sort of economy size and our population size. So I think we have an enormous resource here, and it actually doesn't take it takes a tiny percentage of all the land on Earth to power our needs in 2050 with solar. So what do you see as the problem? Is it just the variability?
So I'm not an expert in solar. I'll give that one for granted. But the short answer is the scale. And I'll quote from the International Energy Economics Conference that I was at in Riyadh in February, where S&P Global had done a study purely on the amount of copper that is going to be needed for wind, solar, and electric vehicles. To meet the targets, they suggested that, don't quote me, but I think it was at least double the amount of copper that's needed today. And given that it takes at least 10 years to establish a new copper mine, to take one problem, for example, one example of a problem with that scale, purely the availability of copper will prevent those targets from being met. That's coming from S&P Global.
Right, but we know how to make copper plants. We don't know how to make a fusion plant yet. On industrial scale. So I'm just concerned about the timescales, and I know there's also there's a bit of politics, especially in Australia, around delaying things like solar and wind. There's all this discussion now about nuclear. We have no regulatory framework. That takes a long time to establish.
Yep.
We have no expertise in the country to underpin that. That also takes a long time to establish. And fusion will have similar issues.
Well, may I
Yes.
just add something more? So in an attempt to develop laser fusion, you're going to enable thousands of other technologies. And that's where we see as a...
bad thing to do.
I'm not arguing this. I'm very biased on that. Is it the best
I
option?
just don't think we should say, we all know about the problems with solar and put it to the side, and let's all focus on these things that are much further down the track. We don't have the time.
Absolutely, but so we need all the energy that we can get. So every single solar and wind project that is being done, we absolutely need desperately because of the total supply of energy. But if we purely rely on wind and solar, AI, data centers as we know them, there's just not going to be enough power for them. So right now, my opinion is we need everything that we can get, and that was reflected in the International Energy Economics Conference. Absolutely, it's an issue in terms of the timeline to get fusion ready. There is a roadmap put out by the US, which is sensible, which is their decadal plan of their first pilot plant within 10 years is a roadmap to get widespread distribution by 2050, so fusion is part of the energy mix by then.
All right, I think I'm getting the wrap up there. So look, can you please all join me in thanking the panel? And I think I'm going to